Thanks for coming. I'm frankly surprised to see this many people here. Between the party last night, the SpaceX launch this morning, and the code sprint going on in the next room. Thanks for showing up. This is Entities All Up in Your Business Logic. We're going to do a pretty high-level overview of the Entity Validation API in Drupal 8. It's going to start off, it's marked as an advanced class. It's going to start off pretty rote and then sort of skyrocket into the actual code base from there. We'll do some code examples at the end. Who am I? Name's Dan Hansen. I come from the faraway land of Atlanta, Georgia. I am lead developer at the Savant Group. We are a sponsor here, silver level, I think. We're the only people with the booth still here, so if you want to step out and maybe try to grab a t-shirt, that just saves us some things we have to pack. So I've been a Drupal developer since I started working with Savant, which is about 2011. I started with D6, and I've been working my way up since then. I'm also really, really into Legos, just because I feel like I need to put hobbies on here. And here's a picture of me with Skywalker. So, what is validation? Validation is conditions placed on data to ensure that the data matches expectations. It's basically how we get what we want in the data that we have. We prevent the submission, creation, or update of data that's incorrect or malformed. We want to keep that from being altered in such a way, just like we want to keep from being created in such a way that it is incorrect. We can also check quality of existing data. Always useful to be able to go through and say, hey, this is wrong, if you brought the data in from a different source. Contextually, we're as far as Drupal goes, we're basically referring to data submitted by forms or other means on the website. And we'll get to what I mean by other means in a second. Where validation happens. Client-side, hopefully you guys kind of have an idea of the difference between client-side and server-side, but client-side validation is usually JavaScript-based. It's included in some of the spec of some of the newer HTML5 fields. For example, the email field will do a basic check to see if it looks like an email address before you can pass it along. Easy to display, it's also easy to circumvent. Since it's JavaScript based, you can essentially go around it. If you're doing a post to a form or something like that, or a post to a page, you don't actually have to use that form. You could just post to that page. So we're not really going to talk about client side in this because it's not really where we're targeting. We're targeting server side. It's in the code that receives the submissions. It takes care of everything that comes into the actual Drupal environment. Drupal handles some automatically requirements for like IDs and being unique and some of the form field settings that you could set, like making this required or doing a min-max on a numeric field, things like that. For secure inputs, you have to do server-side validation, and it can be a real big black box for users if it's not correctly handled. And what I mean by that is you have to push out some sort of errors or messages that really describe what the problem is with the data to make it useful for anybody to submit to it. The old way is validation in Drupal 6 and 7 revolved around forms. That's where you put in your business logic. That's where you hopefully had people accessing the data and putting in the data. Drupal 6, you had hook validate, which was a lovely little hook that basically lets you determine what you needed to validate on a form. Drupal 7, you kind of had hook validate still, but the proper way to do it was create a validation callback. You'd use hook form alter to actually hook into the target form using the form ID if you could, and then you'd add a callback to form validate. And that's all well and good, but there's a problem with that approach. It only works for forms. Forms are not the only way you create entities. Any entity that is created programmatically is going to skip that form entirely. For example, rules-based node generation. I've had a lot of instances, particularly in trying to handle emails, where you would use a rule to generate a node to sort of log what's being sent out on an email, and that rule, that node generation in the code is just not going to be tracked by any sort of form validation. REST API entity creation. Anything that comes in through a REST API has to be revalidated the same way you would do it with the form. Otherwise, basically you're just duplicating code between two different places. Secondary forms. I've had a lot of instances where I've had to make a slimmed down version of a form for an entity, something along those lines, where you have to, again, duplicate that form validation, otherwise you don't get it. So there's a lot of places throughout the older systems where you could just poke holes and basically create an entity without ever having to go through any sort of validation checks, and then end up with these garbage entities. A solution for all that is Drupal 8's Entity Validation API. Forgive me, it's still coming down off some kind of cold. Overview of the Entity Validation API. Standardized entities in Drupal 8 means that we get standardized constraints, and we have reusable constraints that we can use for different kinds of entities. These constraints are implemented as plugins, which means you can create some, you can add them in through modules. Plugin system in Drupal 8 is very powerful, very useful. Constraints are attached to entity definitions. That's partially true. They can also be attached to field definitions on entities. We'll go over that a little bit more in the code demonstration. Where to add constraints? Why, in the code, of course. You'll modify and attach to entities using hooks. Specifically, hook entity base field info alter, and that's a mouthful to be sure. If you're going to do any sort of validation constraints on an entity, on its base fields, like say its title on a node, anything that's in that core entity table, you would use this base field info alter. For fields that are attached to an entity, you'd use hook entity bundle field info alter. And then there are some kinds of constraints that you could actually add on the entity level as opposed to on the field level. And for those, you would use hook entity type alter to actually join that constraint to the entire entity instead of just a field or a component of it. If you're building custom entities, it's really simple. You don't even have to use hooks. And you'll actually see this on a lot of entity types in core. You could just stick the validation constraint right onto the entity itself. As with most things in Drupal, somebody's probably going to build a UI for this. If anybody wants a really nice project, feel free to try to build out a UI for these hooks. So custom constraints. Sure, why not? You build it out as a plugin. The easiest way to do it is to extend existing constraints if you want to update the message. I'll have an example in a second that actually demonstrates extending unique constraint on a field. If you're building a custom constraint, you have to build a custom validator to check it, implementing the validate method. Once again, I'll have that in the code demonstration just to get a better impression as to what that looks like. There's kind of a naming convention. You can override this, but it's basically my custom constraint validator. Constraints already in core. So I hopped around the internet for a while trying to find a list of what all constraints there are. There's not one. There is a blank documentation page right here. And point of fact, I'm actually planning on spending some time in the sprint working on said page. So you can find it in the documentation. There are several constraints that you could actually just search for the word constraint, and you'll find it in the code base. There's also a validator section of core that has most of the constraints in it until the proper documentation gets up and running. But bear in mind that there are also constraints all throughout the the module system, the core module system. And those are going to be specific to specific items, like you're going to have a unique username constraint on the user core module. So there's some that are in core for like unique items and required items, things like that. There's some that are in core modules, but none of them are really properly documented right now, except for the documentation of the actual code base. So let's take a look at some actual code. I built a small dummy site here using Drupal VM. If you have not used Drupal VM, very useful. Spins up a Vagrant box, gives you everything you need right off the bat. And it's just a little site based around Legos. You've got a little content type that has just an image, some information about it. Well, I wanted to add a constraint where the set number field has to be unique. So to do that, let me pull up PHP Storm here. Is this too small? Do I need to make this larger for you guys?
It's pretty tiny.
Yeah.
At least back here in row 3.
It looks great in row 2.
Yeah. Scale. Let's try. That's gonna be larger. Okay. Okay.
Oh, much better.
So to actually get that constraint in place, I've got a custom module. I'm in my modules custom, and I've built a Legos module. And so to get that constraint, I'm actually going in and creating something, source plugin validation constraint, which is kind of a pattern you'll see with all these constraints. The one I've actually built out is actually, oh man, everybody showed up now. I've already got through most of the slides.
Word got out, man.
Yeah. So this constraint that I've built out, for those of you that are just joining us, is actually, I've got a custom node type called Lego sets. The set number needs to be unique, and so I needed to build out just a custom constraint for that particular field. And so what I've done here is extend the unique field constraint. You can see here this is very straightforward. All this really does is take the unique field constraint and goes ahead and adds its own custom message to it. Well, buddy, the code is already taken. So, and then to actually get that applied to the entity itself within the module, I have used the hook entity bundle field info alter. Since this is a field and not a base property of the entity, I'm using the field info alter. And because I'm actually going in and not doing this on the entity level, I can match the bundle set, or match the bundle to my content type, find and check the actual field that's there, and then just add this constraint that I've built out over here. So code unique. If I had arguments, they would be present in this array right here. And now, when I come back to my actual field here, I'll just copy this number for demonstrative purposes. So content, add content, Lego set. Oh, there we go. I knew I couldn't remember how to spell Porsche. And so if I try to build out the same set here, it is broken. Awesome.
No, totally awesome.
Yeah.
Is the module enabled?
That's a good question. I thought it was.
Did you clear your cache?
For all involved, it did work this morning. Z number. Well, let's do this. I will go ahead and try to resave, and of course it saves. Well, this did work this morning, but the bottom line is this is how you add a constraint for a particular field. You would go ahead and use this hook to tap into the bundle and the particular field that you wanted, add the constraint, and it may just be this constraint is actually busted because I was tinkering with it. Anyways, there are other ways to apply constraints. You can even do it on multiple fields. There are plenty of examples in Core, and I think I'm actually going to pull up one for that since this one seems to be failing so completely. For example, on comments, you have different issues depending on the username and the user ability to post a comment, whether or not the name and the UID have to match, things like that. You can see here that we've got the comment name constraint, and this is a little bit bigger, but mostly because they have a couple different labels they have to add here. You've got the comment name ID, the different messages. Because this covers multiple fields within the base entity, you actually have to have this cover fields method in here, function rather. And then you'll see that this validator is here next to it, which actually is what runs the whole checking of the object. It's got the validate function in here, where it pulls the author name and the owner ID from the entity, and then just makes all the comparisons. You can see here the model for that, and I would really go to Core to find this model, where you say build violation. You give it the message that's going to be passed back along with any replacements, just like you would on like a T function or an L function. At path name, that's going to be for whatever field is actually causing the error, and then add violation, and that'll actually add it to the context that you supply up here. So there's a couple different violations you can actually see that are run through here, depending on just those two fields on the comment. And I mentioned before that on the entity, if you get the chance to actually define the entity, you don't have to actually use a hook. So if we look at the comment entity down here on constraints, you'll see that they've supplied the comment name, which is what allows it to use that constraint. All right, and I think I've kind of blazed through this, so that's basically all I had. Does anybody have any questions?
Is there an implication from the fact that you have to pass in which specific fields that it covers, that even if a constraint was identical in functionality otherwise, you would have to duplicate it in order to use it on a different entity type that had essentially the same thing going on but happened to use a different machine name for the fields?
Yes and no. The names that you have to pass in for those for that constraint are only because that's a entity level constraint that's handling multiple fields. If it was a base level constraint, I would go ahead and use the entity bundle base info alter. If it was a field, a single field, I would just use this field info alter. So that's really going to be entity specific in the first place. It's still probably possible to reuse that constraint, but like you said, you would probably have to have the same names and the same fields on that other entity.
And then in the case of, I assume the way this works when it's working is that it bubbles up to the caller. So if you've got a constraint failed message, then that would get shown as a form error on a form.
That's correct.
What happens in other places where the entity is being created? Like, do I have to do something when I'm providing my REST API stuff to expose that, or does it magically happen for me?
I believe it magically happens for you, and I think the way that it actually happens is it throws an exception. I'm not 100% on that. If you did have to validate it by hand, there is a validate function that's on all entities that will just run all the validation for that entity, which is kind of why you have to join all of those constraints to the entity itself. So there is an attempt to make it as automated as possible, and if it's not automated, then it is. They try to make it as easy as possible beyond that.
So the validation runs on every entity saved.
Every entity saved and updated, yes. I believe. I have not had the opportunity to test it in every case, but I think it's just a component of saving.
So like during a migration or something, that
Yeah.
validation would actually kick in during the migration.
I believe so, yes. Any other questions? All right. Well, then, if you're looking to see SpaceX, it may be in the air for all I know. Is anybody keeping track?
That's why
It launched. You couldn't see anything.
Let's see.
The cloud cover.
It's already
was-
overcast.
Yeah, way too bad.
All right. Well, thank you guys for showing up this early and in this number, and I appreciate it.